Good morning everyone. Today we are going to see shear force and bending moment diagrams for a cantilever beam. Myself S.K. Karthikeyan, Associate Professor, Department of Mechanical Engineering, Kongunadu College of Engineering and Technology. Now coming to the problem, this is the arrangement they have given as a diagram. So they are simply asking shear force and bending moment for the given arrangement. You see there are 4 point loads acting right from free end, that is at E you have 30 kilonewton, at D 70 kilonewton, at C 40 kilonewton, at B 60 kilonewton, and the distance are 0.6, 1.5, 2.4 and 6 meter from the free end to fixed end. Now coming to shear force calculation, you do the calculation from the free end. So there is from the E. Now I am going to start from SF at E from right. So there is 30 kilonewton. At E you have only one point load, that is 30 kilonewton. So S of E is 30 kilonewton. Then the next one is in between value, that is shear force value. So shear force between E to D from right, S of ED is 30 kilonewton. First you write the previous answer, then you find any load between that distance E to D. Actually there is nothing, so the previous value is the answer for shear force E to D. Then coming to next one, shear force at D from right, it's going to be S of D equal to previous answer plus at D you have 70 kilonewton, so 30 plus 70 is going to be 100 kilonewton. Then next one is shear force between D to C. So you first write the previous answer 100 kilonewton, then you see if there is any load between D to C. Actually there is nothing, so it's going to be 100 as is the answer. Then shear force at C from right, S of C is previous answer plus at C you have 40 kilonewton, so 100 plus 40, 140 kilonewton, so 140 is the answer. Then shear force between C to B from right, so it's going to be first you write the previous answer 140 and you see if there is any load between C to B. Actually there is nothing, so as usual 140 kilonewton is the answer. Then shear force at B, it's going to be previous answer plus 60, so it's going to be 200 kilonewton. One more thing, that is between B to A, that is as usual same answer, 200 kilonewton is the answer. Then we are going to find bending moment for that arrangement. Before that we are going to construct the diagram for the values. You see all the values are positive, so you first draw a common baseline, then from that you construct the shear force diagram. So the first answer is 30, so you simply mention 30 at some distance. Then between D to E it is same value, so you draw a horizontal. Then at D it is going to be 100, so you draw a vertical line towards up. Then from D to C it is going to be 100, so you draw a 100 line, 100 value line as a horizontal one. Then at C it is going to be 140, so draw a vertical line towards up. Then from C to B it is going to be 140, so draw a horizontal. Then at B it is going to be 200, so it is going to be vertical line towards up. Then from B to A, it as usual it's horizontal, so you draw up to A. So this is the diagram we are looking for. This is shear force diagram. So one more diagram we have to draw, that is bending moment diagram. So for that I am going to do the calculation from the free end. As usual you mention do the calculation from right, that is bending moment at E from right. So BME equal to 0, that is because there is a rule. When you go for calculating bending moment at the free end mean, it's going to be 0, always 0 at the free end. Then the next one is bending moment at D, so we are considering from right. So 30 is the free end load, 30 into 0.6, that is force into distance, vertical force into horizontal distance, so it's going to be 18 kilonewton meter. Then second one is bending moment at C from right, that is BMC equal to 30 into 1.5, so the free end load is 1.5 meter up to C, so 30 into 1.5 plus 70 into that particular portion distance 0.9. So finally you got 108 kilonewton meter. Then as usual, bending moment at B from right, do the calculation from free end load 30 into 2.4. So that is the distance up to B. So 30 into 2.4. Then second load, that is that D, 70 into 1.8. 1.8 is the distance between D to B. Then plus 40 into zero point 0.9, that is the distance between C to B. So finally you got 234 kilonewton meter. Then the last one is bending moment at A from right. So that is 30 into 6 plus 70 into 5.4 plus 40 into 4.5 plus 60 into 3.6. So finally you got 954 kilonewton meter. So for that I am going to draw the diagram as usual. You draw the baseline. So here we have to consider all the things that to be acting towards down. So the diagram should be in negative portion. So you mark the points 18 and 108, 234, 934 first. If the shear force diagram having horizontal line means you have to draw a inclined line in the bending moment diagram. So you see the distance between E to D is horizontal, that's shown as an inclined line in the bending moment diagram. Likewise you have to complete the bending moment diagram. So this is the final answer we are looking for. So that's all. I have completed point loads acting in the cantilever arrangement. So thank you all. Thank you once again.